To lead today's discussion, please welcome moderator Rajiv Chand.
Hey, everybody. Good morning, and welcome to the second keynote here on the South Stage at RSA. It is my honor to be the moderator for this session. The topic that we are going to cover today is genomics, which one could clearly argue there is no more personal data than your genome. We are really privileged to have today 4 voices, each from very different perspectives, to lead this dialogue on what is the size of this genomic opportunity, what are the privacy considerations, and what happens when your or my genome shows up on the dark web. And so the privacy, security, and opportunity sort of considerations. We have the voice of the physician, immediately to my left, Dr. Patrick Cornea. We have the voice of the genomics expert, Kathy Hibbs, Chief Legal and Regulatory Officer of 23andMe, and Dr. Cornea, I forgot to introduce you as Chief Medical Officer, Kaiser Permanente. Immediately to Kathy's left is the voice of the patient, the voice of the consumer, if you would, Sharon Terry, President and CEO of the Genetic Alliance. And immediately to her left is Mike Wilson, who serves as Chief Security Officer of Molina and was Chief Information Security Officer of McKesson. Everybody, please join me in welcoming Pat, Kathy, Sharon, and Mike to RSA. So, before we begin, how many folks in the audience have had their genome tested? Okay, so 20-30%. So, Pat, I'm going to turn to you first.
Sure.
What is the size of the impact that genomics will have on health outcomes, and in what time frame?
It's a great question. In fact, one of the things that would probably be wise to do is to have a common understanding or level set on what we mean by precision medicine and genomics and how we think of that as a really important tool. When you think about it, we've been on a march towards more and more precise medicine for a long, long time. And in this case, what we think of is genetics as one of an array of different tools that we bring into consideration when we're thinking about how to support and guide and help our members and our patients make really wise decisions, taking into account their genomics, taking into account the environment that they've lived in, taking into account lifestyle and diseases that they already have, bringing all that information together to help them to better understand what their current and future risks might be, what different kinds of treatment that we might have to manage a disease that they have right now are best suited to that array of different circumstances that they find themselves in. What are the genetics of a tumor that they have that can guide the therapy that we put in place? And what are the implications, especially very early on, of having genetic risk factors for the way they make their choices going forward in a way that helps them to achieve their own personal health goals? Now, those are all really very, very powerful opportunities, and they're opportunities that we're working with systematically at Kaiser Permanente even now. It does bring forward some important challenges, too, that we grapple with. There are between 800,000 and 900,000 genetic markers that have been associated with human disease. There are north of 75,000 genetic tests available. It's really a small fraction of those that guide decision-making when it comes to interaction in the clinical space. And so understanding what those genetic markers mean for the populations that we serve is critically important. The obligation, I think, is actually embedded in the term precision medicine. If you don't understand the implications of all of those different genetic markers and you don't understand how they apply to the specific circumstances of the individual that you're working with, it's not precise. And so we need to be very attentive to the idea of that. And there are some things that are true about the way the information around genetics and genomics has unfolded that we need to take into account. The lion's share, the last I saw, 75% of individuals who have participated in research that is aimed at understanding the implications of genetic markers are Northern European white population. And so it's very difficult to know if things that we draw from that research applies to the very diverse communities that we are working to take care of. And so making sure that we understand that, critically important. The other is, as we create algorithms that support a very, very complex set of decisions, are we embedding those biases into the algorithms in ways that does not benefit or create a more precise and higher quality decision in that interaction between the patient and all of that information and the clinician? And beyond that, of course, is does that same thing apply when an individual is taking what they know about their genomics and exploring what information is available on the internet to try to make decisions day to day without that interaction with a clinician, which I think we have to accept is a part of day-to-day reality right now. At Kaiser Permanente, we are using these tools to screen for disease. We're developing the technology to be able to track.
How important is it? So I'm going to put on my old investment banking analyst hat. And you had bullish and bearish. So how bullish and bearish are you? In what time frame?
Okay, we're very bullish on this, and in the near term. In fact, there's really very important things that we could do systematically across an entire population of 12.3 million members that we could draw benefit from even now. Going forward, I'm also very bullish about it, but I also have concerns that we need to be able to approach the unfolding information very thoughtfully so that as we incorporate it into those interactions, it's actually adding value. So I think it's great opportunity. It's just that right now we're in a space where the hype is well ahead of the reality, and we need to be able to manage that journey effectively.
Kathy, 23andMe is clearly the pioneer, if not, one of the most important pioneers in the space. How do you sort of size the impact to health outcomes in what time frame?
Yeah, so what's unique about 23andMe is that we are an FDA-cleared over-the-counter genetic test. So Patrick was talking about the fact that there are maybe 75,000 genes that have been associated with disease. We test only for a small fraction of those because we only test for and report on the genes that have been well studied. There's peer-reviewed, published evidence that shows that we do understand that these diseases have a role in causing these genes have a role in causing diseases specifically, where it's been really well established. Notwithstanding the ethnicity issue, we do have to explain to people, as Patrick pointed out, that most of those studies really were in a European population, and so while there may be data that indicates that the function is the same in people of other ethnicities, it is not as robust. So we do that. So the genes that we report on are ones that are well recognized. If you say to your doctor, 23andMe says that I have the marker for a disease called hemochromatosis, your doctor will know what hemochromatosis is, and then will take other tests to determine, because this is one, it's a very important preventable disease. If you happen to have the hemochromatosis marker and have hemochromatosis, it means there's too much iron in your blood, and the treatment is to basically draw your blood, to do a frequent blood donation, if you will, to reduce that iron. And that the alternative to not preventing that is organ failure. And it's
That doesn't sound good.
And that's not good. And so you want to catch and prevent those. About 12,000 people a year in this country still die of hemochromatosis because we find out too late. It's the actual organ failure that's happening that causes them to go to the doctor. And it's not cost effective to test everyone for hemochromatosis. We wait and see if you develop it, and then we'll test your family members. That's how it works. The advantage of 23andMe is that people can be tested even though they don't have a family health history, and they wouldn't qualify because they wouldn't meet the clinical guidelines to be tested in a medical context, meaning their doctor won't recommend it and their insurance isn't going to pay for it. And so for things like hemochromatosis, we have lots of patient stories and customer stories where we've identified entire families that actually suffer from this and it hasn't been discovered. And if we do that, we have the opportunity to prevent the onset of that disease. Another example is about 50% of the people that we find with a mutation in the BRCA gene, which is very associated with increased breast, prostate, and ovarian cancer. About 50% of those people don't know their ethnicity. They may not know that they have an Ashkenazi heritage, which is important for that particular marker. And they don't have a family health history of a cancer that would have qualified them for medicine. So the role that we play is that we give customers the opportunity to get a test that may find those situations where they are unlikely to be tested in the medical system, and then we open up their entire families to what's called cascade testing for the medical system. Because we do know that people with these genetic conditions, particularly those ones like I've mentioned where there is some possibility of at least mitigation, if not prevention, get missed in the healthcare system. And so that's really the advantage of 23andMe.
Great, so I'm going to jump to kind of topic number 2 here, which is privacy, but just to also level set with the group, this is going to be a highly interactive session. So in about 20 minutes, I'm going to invite everyone to ask questions, and there's 2 mics in the aisles here, and so that way everyone who's had a test or is considering a test could even just ask a question as to kind of the outcome benefit. But I think all 4 of the speakers here would probably generally agree that we're excited about kind of the opportunity of genomics, even though there might be some kind of hype-ish kind of qualities today. So let's jump to privacy. And so Sharon is the person who literally has driven the landmark kind of bill in this space called GINA. So could you talk for just a few seconds on what exactly GINA is? And then the broader question of, can genomics data be used for employment considerations? Can genomics data be used for health insurance, pre-existing conditions? Can it be used for life insurance purposes? Talk to us a little bit about kind of the privacy considerations around genomics data.
Sure. So I have to state that I led actually a massive coalition of tens of thousands of individuals who helped to get the Genetic Information Non-Discrimination Act passed. In 2008, we spent almost 13 years fighting to have it passed. It protects individuals in both health insurance and employment from being discriminated against based on genetic information.
So it can't be used for pre-existing conditions.
Right. So, so an interesting piece of this is if a person also has a symptom, so let's use the hemochromatosis example, they have mutations in the gene associated with hemochromatosis, the insurer and the employer cannot discriminate against them based on that genetic information. However, if they're symptomatic, they can use that information just as they can about all of our health to discriminate or set premiums, et cetera. GINA does not cover long-term care insurance and life insurance. And while we started out now 20 years ago trying to get that done, it was impossible for us to get those provisions through because those particular kinds of insurance really heavily rely on prediction. So what we're finding is that individuals are more and more interested in their genetic information. You can go to, the gas station or a fast food restaurant and hear people talking about their results from DTC consumers or from the doctor. What I'm most concerned about is that we do protect privacy, but at the same time that this information is available to use for research, particularly you're getting the kind of porosity that we're seeing at a place like Kaiser and others, where clinical and research integration is really happening rapidly, and that's very important. And so I've developed a system that I've worked on for years and have a partner called Luna DNA, whereby we allow individuals to keep a string on their data. So they deposit their genome, their medical record, their patient-reported outcomes, and they get to tell who gets access to this information. And the data stays in the repository in multiple databases with lots of foreign key structures, et cetera. And the questions come to that data. So sandboxes, virtual compute environments, allow these questions to be asked and even spin up whole communities around the questions. For me, trying to drive a consumer-driven healthcare system, like we have now done in ride sharing and music and other places, I think we're going to need to see an integration of these systems such that the consumer is central, the focus, and in fact gets rewarded. So in our system, we have SEC qualified shares given to individuals for sharing their information, and that means we're overseen by the SEC, and that gives us another level of accountability and really moving people from being subjects or patients to being partners.
So would all 4 of you agree that my genome is my intellectual property?
Yes.
My genome is, so each person's genome is their intellectual property.
Yeah.
Yeah, I don't know that I would even restrict it to intellectual property.
Just your
I mean, they own it.
So a person's genome is their data.
Yeah.
And companies are custodials of that data, not owners of that data.
So yeah, but I think, Rajiv, what's happening a lot of places, and even in major medical centers that I work with, is often the major medical center will tell us we own that data. Now there are laws, and
That the major medical center owns the data, or the patients own the data?
they'll say lip service, the patient owns the data, but then when you get to it and ask for wide sharing or contributions of these data to various databases, there are some concerns about their business models, their restrictions, sometimes using even HIPAA to kind of cover what they're doing, when in fact HIPAA does not disallow that kind of sharing. And I think, and Kathy probably can speak to this better, but there are now actual provisions in the law that allow every one of us to get any data we want from anyone who holds that data. But I don't think we're finding data as liquid as we want it to be, and we're finding some disincentives for sharing it, especially from institutions, pharmaceutical companies, et cetera.
Yeah.
So Sharon, the next question is for you. So 2 years ago, I hosted Facebook at one of my private summits. I asked about Cambridge Analytica. I actually hosted Cambridge Analytica at my summit last year. So is there a Cambridge Analytica in the waiting here, with kind of this ecosystem of genomics kind of sourcers, researchers, monetizers? Is there a Cambridge Analytica kind of waiting here?
Yeah, so I think, first of all, there's already the monetization of data that we actually have nothing to do about, which is why in our partnership with Luna DNA, we made sure that the people get the shares rather than everybody else making out on the data. I think there's also nefarious use of data happening already. We've seen that, especially in medical record breaks, but also in genomic information. And I'm very concerned, not so much maybe about an individual, but that individual's genome actually is a representation of their family, their ancestors, their children. So
Right.
when I share my genome, I maybe should be asking my parents and my children for permission. I don't, but I could. And I think the other thing we're looking at here is this is a great place to actually discriminate against populations.
Yep.
So to start to come out with information that might be misinformation about a group of people based on what we think is a population-wide genomic study.
Rajiv, you asked that question about am I bullish on the potential for genomics in helping people achieve their health goals? I'm very bullish on that, but I think we're already seeing behavior in the population that suggests they've begun to pull back from the free sharing of information because they've seen the information that they've put out in the marketplace used in ways that they didn't anticipate, that they are uncomfortable with at this point. And as we get further and further into things that are more and more private and from which de-identification is incredibly difficult, we may see circumstances where populations actually withdraw from that opportunity because they've lost trust that the system can protect very, very valuable and potentially challenging information for them.
Yeah. Well, for 23andMe, I think the point Sharon is making is really important, that I don't think we as consumers or patients really understand our healthcare data and how that's used in the system. I frequently point out to people, many of the folks in the room I'm sure are familiar with HIPAA, but a lot of people don't understand that the P in HIPAA is for portability, it is not for privacy. And the amount of information in your healthcare records that HIPAA covers is a tiny segment called PHI. It's not most of the medical outcomes. And to the kind of commerce point, there very recently, the CEO of one of the major software companies that provides backbone billing software to medical providers, hospitals, and the like, basically said that they opposed data sharing by patients because it would impinge on their business model. And doing that, of course, prevents us as individuals from, changing doctors, getting a second opinion, keeping track of our health records so that when we do have a disease or a condition arise, we can easily say, no, I've had this procedure, or I've never been on that drug, or here's my dosage information. So there are real impacts to people trying to silo data from the individuals whose data that is, and there are commercial reasons that people are doing that and are concerned about keeping that data, not just from researchers, but from the individuals whose data that is. But for 23andMe, historically, and this, way back before Facebook or any of those other things, because fundamentally the purpose of the company has always been healthcare, we have always used essentially the same standards that apply to human subject research for clinical trials. So there is an external ethical board called an IRB, or an institutional review board, that reviews the studies that we do, and they also review the consent requirements. You have to get knowing and informed consent to do medical research. And so when folks consent to research inside of 23andMe, they're not defaulted. It's not like the Cambridge Analytica situation. They actually have to proactively consent at 3 different levels to the actual research in a very, very specific way, so that so that we have knowing and informed consent. And I think that that's an area where those ethical standards that apply in the medical system can be examples for some of the other, some of the other parts of technology, if you will, that have a kind of more of an ad tech and a default consent model to hopefully prevent that. Now, that comes out of a background where there were abuses, the Tuskegee situation. So it's just that the medical research, because those issues arose 70, 80 years ago, there are some standards there that can be applied, and certainly we adhere to those, but that I think could give some level of public trust if we can get people to understand and then differentiate and make informed choices about who they work with, where they use their data, and what they actually consent to.
Yeah, this is actually a question both for the room and for the group here is, do we feel that patients are giving informed consent? Do we feel like patients are giving informed consent here? They understand how their genetics data is being used?
I think they definitely do in terms of our customers, and it's always funny if there is a kind of, a very hyped press article. If you read the comments, it'll say something like 23andMe is doing research with GSK, and then if you read the comments, it'll be our users saying, well, duh, of course we know that. We consented to that. But I don't think that that's universally the case. And we know, for example, on our own website where customers and potential customers are, the area of the website they spend the most time on is the privacy and transparency section. So we know our customers are looking at that information as they're trying to make a decision about whether they want to make a purchase and take a test or not. But I don't know that I think you said one of you said that there were how many tests out there? 75,000?
There are 75,000 plus tests and 800,000 plus markers associated with human disease.
So that, I don't know that we can say that there's a standard that's consistent across that level of
So Sharon, I see you smiling there. So as the voice of the patient, let me ask you your thoughts on this question. And not for 23andMe specifically, just in the market, do we feel like patients and consumers are giving informed consent?
Yeah, so I think that's a really hard question that most of us, there's been those sort of joke consent forms where one of the terms is you give away your firstborn and people signed it anyway. So there's both the people who don't read it, there's the people who try to read it and can't understand it. There's the complexity of all the legal issues that are usually embedded in them, and they're very long. Ours is only 4 pages, and we made it really consumer friendly. But I think still, how does any one of us know what we're consenting for the future and what we may or may not find out and how that's going to strike us then? So I think the best we can do is more engagement and process than just a form. So in our case, we really like to say, what does long-term engagement mean? How do we embed this in communities that can help support you? And particularly in underserved and underrepresented populations, they are not being given the same advantage that, for example, a 23andMe.
Even 4 pages feels like too much. Even 4 pages feels like it'd be difficult to have most people digest 4 pages.
Well, and I think, our current structure was launched by Tuskegee and other very bad experiences. That's been a long time, and it has been updated to be sure, but the leading edge of advance is moving much more rapidly than regulatory or evidence associated with that. And so I would argue that the consent that I give today about the use of my genetics may be fundamentally different than I give in a year, because things have changed so much that I didn't understand then what I was signing up for. And so it is a moving target. It is quite challenging, and I think we should not draw false comfort from the way the structure is set up right now.
So Mike, we have this significant opportunity with sort of very significant privacy considerations. Question for you. So what happens I think one could clearly see, even from this past week with MGM, every company can get breached at some point in time. I don't know if you'd agree or disagree with that, but assuming that you would agree, what happens when my genomics data gets breached and gets sort of revealed on the dark web? What happens?
Yeah. Well, it's interesting the security guy gets asked a privacy question again. So just as I'm thinking about this topic, and I'm finding this dialogue very interesting, but it's a little challenging from a security and technologist perspective, because in my personal view, privacy, and I mean this with utmost respect, the P stands for philosophy. And I mean that respectfully, because it's an ongoing dialogue and discussion around some very complex issues. And so when I've had a couple of decades in healthcare. Before that, I was in more financial services and a few other things, and very much came to the health industry with a view of, okay, do I really care about what the data is at the end of the day? Yes, I do. But somebody's defining why I should care, my colleagues. I need to protect it, right? And I need to sort of put it in a vault, do things to it, and all the rest of it. And so how do I protect it? And interestingly, as I've sort of unfolded the conversation, again, dealing with colleagues and the philosophical issues around the data itself, I realized that healthcare is very unique. And genomic data in particular is an example of that uniqueness. And there's terms that are out there in the technology setting around immutability and so forth. And if you think about data and data persistency, genomic data is as relevant 100 years from now at an individual level as it is now. I'm being extreme in my thought process, but how then do you think about that to protect something where you don't know what the risks are in 50 to 100 years? And again, I'm being extreme in my view for a point. So in terms of the breach concept, the reality from my standpoint as a managed care organization, chief security officer for Molina Healthcare, which satisfies government programs, Medicaid and so forth, Medi-Cal in California, similar in that regard to Kaiser. I think about health data in a number of different ways, and I think about the risk of theft, of course, and I think about insider threats, which you would have heard a lot about, and I think about it in terms of, criminals, and I think about how they're monetizing it, and they are, and we can talk more about that, and I think about it in terms of ransomware and in terms of, malware, destructive malware and such, and how that could interrupt my processes and the like. But interestingly, apart from certain biomedical markers and thinking about that under the context of HIPAA, which is the security rule, which is, for health professionals will appreciate that from a security context, sort of as the guiding arm in this country. I think about it similar to how I would think, in fact, literally, how I think about it as a fingerprint. I mean, I don't know if I care that much. It's a biomarker. I need to protect it. Unfortunately, coming back to this philosophy and coming back to this forward view, coming back to the nature of the data and what are the risks that I don't know yet, I have to know the data just a little bit more than that. And then HIPAA and other regulations and laws that are coming out, some of which are coming out at the state level as well, are thinking about the data now in ways that are very unique to healthcare. So we hear this term masking a lot and de-identification. And again, we sort of throw it into the privacy camp, but then you'll find that the security chap has to come along with some techniques to help out, right? In terms of applying the techniques, the black box scenario in terms of your solutions, probably underscored with cryptography and a variety of other things. And those are, clearly security mechanisms and protection mechanisms. And in healthcare, there's this idea of statistics. And in the art of analytics and big data, it's computational statistics on the whole. And so you've got vast amounts of data. So I think about genetic data maybe a little differently. We've got 3.5 billion records.
So can a hacker monetize genetic data? Is a hacker incented to try to get after genetic data?
In and itself, probably not. Combined with other data, yes. So it's like the uniqueness of a medical record in itself and a health record, and all of these terms have certain definitions, but in and themselves are telemetry. So can I monetize packets on a network? Yeah, I probably can, given the context and what the packets are telling me and all the rest of it. Can I monetize genomic data? Clearly, yes, but only with context and additional information. Information about, for instance, the matching of me. Generic data is all around us, right? For instance, genetic data and so forth. It's no different than my fingerprint in some respects. It's no different than a biomarker from a lipid panel. However, the context of that lipid panel is it has my name against it. And all of a sudden it has meaning to me, right? Otherwise, it's just a lipid panel of some random patient who's, hitting 50 and got a few issues. And so I think there is this combination of data which is unique to healthcare, probably different than financial services, although some similarities. And then statistics is applied in that in protection, and then we apply cryptography and other techniques to mask the data. But the number of times I hear the vendor community, particularly in the halls that we have here, tell me they're protecting health data by masking it. And I don't see, there's only two ways to do it. One is you have a statistician in your back pocket and you're working out on the data set how to statistically de-identify it, and that's particularly difficult with 3.5 billion records. Or you safe harbor, which is basically you obliterate all data and it's useless. And so in the day of analytics and healthcare, and as a security professional trying to enable my colleagues to my right in terms of the use of this data, it's a really difficult problem to think about, and de-identification, the application of cryptography, and then to the next step, how do we apply that in genomic data of 3.5 billion records? Do I selectively, de-identify within it? And that's where the research is. Can we selectively do things? Probably some of the solutions you're thinking about in terms of how do we break this apart. There's 0.5, and again, I'll defer to my colleagues here, there's 0.5% of unique identification within the DNA, right? The majority of it is shared. And so when you think about that, DNA is humanity. I mean, I'm philosophical now. So in a way, yes, there's some very unique pieces to the data, but in my view, only when combined with other identifiers and context, and then we have to play that all out and think about it, well, how do we apply it from a pragmatic standpoint in terms of security and controls, and clearly de-identification of cryptography is going to be a key part of that. So anyway.
There's a couple of dimensions to that I think we should explore a little, and maybe I disagree. First of all, 5% of a very large number is still a very large number.
Sure.
So we have to acknowledge that. And we've actually all heard stories, feel-good stories actually, where somebody who did not submit knowingly their genetic information was actually identified because someone else freely shared their information, and that allowed someone, an investigator, to triangulate on an individual. And you can pretty easily see scenarios where someone is very interested in finding someone who doesn't want to be found, perhaps a spouse who is worried about being found by a stalker or something like that, where that information might be quite valuable, and there you're subjected to individual identification, even though you didn't submit your own information. So.
Yeah, absolutely.
Right,
and just to clarify my point, this is where statistics comes in.
Yep.
So the statistical technique in de-identifying data is this. You have a data set. If I take that data set and it has a certain set of markers in it, let's keep it simple. It has a area code, okay? And it has a biomarker. Doesn't have any other identifying mark in it. Doesn't have my name or anything else. That area code has 100,000 people. That biomarker could be down to 10 people. Is that a statistically de-identified data set in the context of, if I go out to your point, other data sets, can I reconstitute the likelihood and find out who those 10 people are, even ringing them all up, potentially? Potentially. And so this is a challenge with the data set, is that it's not by itself. It's not just a data set sitting in Kaiser. It's just not the data set that's sitting in Melina, or sitting in the pharmacy, or sitting within our DNA, or sitting at 23andMe. It's all over the place in different contexts, and you come up with this idea of longitudinal patient record, which again is a broader concept, but it's basically all of your encounters all through your life collected up in one whole medical record, if you will, including genomic data and all other bits and pieces. That's the holy grail. I don't know where that is. If somebody can find me my longitudinal patient record out there, thank you, because I don't know where the hell it is, right? And I'm in the field, okay? So the likelihood of reconstituting data, to your point, is very valid, and that's why the statistics involved are very complicated. There's maybe 4 or 5 people in the country that are external experts that we don't have on our own payroll potentially, that you can go to as a consultant, for instance, and ask questions around this.
So do you believe that data can be de-identified? Healthcare data can be de-identified?
I think it's a very real risk that we have to guard against.
Yeah. The point I would make is I want to make sure we understand that that's beyond genetics. To Patrick's point that people could use genetic information to identify subjects, that actually happened. Academic researchers in medical context actually identified by name patients in studies from no genetic information, simply from the rarity of the condition and then other basic demographic information that is included in studies. Those were largely the age of the person, the number of siblings they had, and the general region that they lived in, which they were able to conjecture that, you know, a patient who had been in a study at Harvard, et cetera, had to live somewhere in the New England area, and then based on the rarity of the disease, the age of the subject in the study, and the number of siblings that were reported, we're really able to figure out just from that, it's this family in this town and they suffer from this condition.
And even not rare disease, so William Weld was identified by a woman named LaTanya Sweeney doing research at Harvard by his medical record and his zip code, and she used it as an example to show we could identify anybody if we have more than one data set is a critical.
So I think that there's a focus on genetics that is important because I think that that can help us identify better ways to protect the information. But my concern is if people don't know this larger issue, that your healthcare data, it's really important when I go to the doctor that the doctor has my complete healthcare record and doesn't get it confused with somebody else. So if you just think about those situations where you go to the doctor and you use a credit card to pay for your copay, you give him your health insurance card, that has your information encoded to your employer, your social security number, all of that stuff. It's important that your health information be associated to you, and that is all there, included in your health records, because that's how we make sure that we're actually using the right information for the person that's sitting in front of us, not just for a random person who has a very similar name. This is perhaps an opportunity to really make sure people know that and set some standards that can protect all of that information, or better protect. I don't think there's anything that's ever going to be perfect, because you do need it to be associated to the individual or it becomes absolutely useless. But the narrow focus on genetics assumes that we couldn't do this before, and it's been proven that you can do it from that.
There was a great New York Times article in January this year, which had these journalists had access to a very small set of location data, 50 million data points, and from these 50 million data points, they were able to identify individuals who were having affairs. They were able to identify somebody in the Department of Defense who was at a rally in DC with his wife. They were able to, it was just amazing what was able to be done, you know, with kind of a very small amount of location data that was quote unquote de-identified. So in about 1 or 2 minutes, I'm going to open up to the group. So definitely please come into either of the aisles and let's definitely get all your questions. So Mike, I'm going to ask you kind of the last set of questions here, which is year over year. And actually, how many folks in the group are from the healthcare industry? And you may or may not want to raise your hand, actually, given the question I'm about to ask. So we've got a couple from the healthcare industry. So we've got Mike, this is for you, and then for the other friends who are in the healthcare industry. So year over year, the industry with the most reported breaches is the healthcare industry.
Yay.
Why is that?
Multifaceted question. So the reality is healthcare, although changing, is predominantly small business in this country. Okay, so if you think about the likes of Kaiser, even Molina, Humana, others, health systems, even the VA, they're very large organizations, but there's probably a dozen, maybe 2 dozen in this country that are of scale at that sort of size. And that's changing. The dynamics of that are changing over time, similar to perhaps how it changed, in my view, in financial services. So I think part of this is a tax service, okay? So it's a simple idea, but the attack service in an ecosystem where we're relying on providers and partners. An example, Molina has a network of providers that we work with. It's a little bit of a different model than perhaps a Kaiser model, although there's some similarities. And so in that situation, we manage the outcomes of our members through partnerships, through contracts with providers, the local hospital in a particular setting or whatever.
So
it's a little challenging because we're relying on that tax service. Sorry.
It could be a tax surface. There's there's a fragmented ecosystem. Information needs to get shared very fluidly for both clinical and billing purposes. It could be a tax surface.
Correct. So tax service is probably, in my view, one of the biggest areas. I think you're seeing a lot of what you call sort of third-party breaches, and we're all somebody's third party, I guess, but that's the predominant issue.
That's true.
And then the other piece of it is, I think it does come a little bit more to the granularity of the data itself. There is this sort of construct, and again, it's sort of more of a legal privacy construct around this idea of covered entities and business associates and all this sort of thing. But at the end of the day, it comes down to fit for purpose, and there's some basic questions that I ask around, okay, so we're going to move some data for very good reason to a provider. Why are we doing that, and how much do they need? And that's sort of a privacy question too, but it speaks to security in terms of, well, if I can minimize the attack surface of the data I'm dealing with, then there's less I have to protect. It's simple, right? So.
Awesome. So first question, name and company, and then your question very briefly.
Hi, Garrett Schumacher, CTO of Gene InfoSec. So first of all, I'd like to clarify that genetic data alone is identifiable, as was the case with the Golden State Killer. If a BuzzFeed reporter with no genetics or statistics background can identify colleagues based on DNA alone, then most people can do it. So my question is, when it comes to genetic de-identification, I have my own opinions, but do you think it's actually possible to de-identify? And what methods are you taking? What precautions, therefore, are you taking?
So I'll answer that because I think it's probably directed at me. A couple of things. It wasn't genetic information alone. It was genetic information plus basically ancestry records and family trees. They didn't go like, we have the genetic profile of the Golden State Killer. They'd had that for 30 years from the rapes and killings and identify them. If it was that easy, the police would not have any unsolved genetic
But
cases.
genetic data was the kind of the tipping point, the important sort of predicate to the Golden State Killer's identification.
I would say not. They had the sample from the crime scene. It was plugging it into a database, which is a publicly available database where people put their information and build out family trees. It was, this genetic profile is as a degree related to this other profile, and they've built out a family tree from publicly available marriage, birth, death records, and that's how the identity was actually done. So it's a perfect example of a situation where the genetic information alone at this point in time is not able to identify the person. I think the issue there as well, and this is why we have a transparency report, we don't and never have given information to the police. There are some legal challenges that would exist in terms of the police getting records from a company like ours because there's no evidence. We don't know that a customer actually spat in the tube. There's no chain of control, if you will. So it actually, that lack of identity that exists is better protected in a consumer situation than it is in a healthcare situation. The other thing that's really important that people understand is the police use medical samples and medical records now. The BTK killer, the serial killer in Kansas City, was identified using his daughter's pap smear sample that was accessed by the police at the hospital where her pap smear had been on file for 5 years. So again, that's a situation where I think because of the amount of hype in the press and the lack of a greater understanding about, for example, the fact that there were genealogy records that were used, or the fact that, medical samples and medical information has been used in a criminal context as well, we're kind of touching the surface. It's a really important issue, but we're kind of touching the surface and leaving undiscussed the larger information.
What you're saying is it's not just genomics.
It's not just genomics, and it's certainly not just consumer
Any
genomics.
other? And just to chime in very quickly, yes, you can, but you'll eradicate the data. So you obfuscate it completely. That's safe harbor. And I guess if you apply that to the medical record, you might determine sort of an outcome or a biomarker and then eradicate all the source. I'm not sure why you do that, but you would or could. And if you did that, then effectively it's de-identified completely. De-identification, though, as a term is misunderstood. It doesn't mean that it's completely obfuscated. It means it's statistically low likelihood of reconstitution of the data. And I think that then is determined as by an expert witness, generally viewed in the 1–1.5% range is what we use in the industry.
Pat, real quick. and then
Yeah,
we'll
just
jump to the
real
next
quick. That's a really nice explanation of the detail behind what happened in that circumstance. That will get lost when it comes to individuals who are wondering whether or not, or deciding whether they should trust a system with their data.
Sure.
That's probably the biggest. And if they step back from sharing that data and lose the opportunity that we discussed earlier to have an impact on their health, that will be a significant loss.
Yeah.
And so I think we have to take into account also the fact that something that is statistically very unlikely with the computing power that's available out there now is actually statistically
Possible.
doable.
Awesome. Name, company, and then very quick question.
Dr. Thornton, physician, researcher, epigenetics. Genomics is going vertical. Please, more data. What I do worry about is not the individual. I worry about the population and state actors. It won't be long before you'll be able to profile an entire population and look for vulnerabilities within it, which could be useful for antagonistic state actors. Are we worried about that, or is it unavoidable?
Yeah, I think we worry a lot about that. I don't know if it's unavoidable or not, but I think what at least we're doing is saying to various communities like Native Americans in the US or various countries that are worried about this might happen to them if they don't start to take control themselves, is what tools can we put in place to limit the access to that information. Back to the de-identification point, we can't de-identify the genome ultimately, perfectly, but we can limit access and have the people themselves be in control of those things. That said, that is probably my primary concern around genomics, is that whole populations will be mischaracterized, that bad actors and states can do it. And we see it in our country in a variety of ways already, not using genomics per se, but that certainly that could start to become part of somebody's philosophy and thought pattern.
Sharon's based in D.C., so just,
Yeah.
Sharon's based in D.C. Great question. Next question. Name, company, and very brief question.
Caleb Barlow, CEO, Synergistic. We're certainly in a world where nation-state adversaries, as this audience well understands, are after genomic data. They put it right in their 5-year plan. They're actively out, sending the police out to gather genomic data on individuals, and they'll steal it. In fact, probably a third of the people in this room have had their healthcare records stolen. But let's talk about the legitimate side of this, because what I think is so fascinating when we're up against a nation-state actor is not only can they steal data and get it nefariously, but they can invest in all of your companies, which they've done in several of you on stage. It's pretty hard to find a genomic testing company, a DNA sequencer, or a laboratory that doesn't have some tentacles to Chinese venture capital. How do we deal with that?
Well, I think at the moment, that is something that CFIUS, which is a federal agency that looks at the actual international investment, is really taking a hard line on. And so that is something that in the last several years has really reduced. And there actually have been several transactions even that were actually completed, and then the government actually forced a disgorgement of the asset because of the concern about that. It's something that, frankly, our CEO said several years ago, told people in DC that they needed to be concerned about this exact issue. There are some other things, though, at the moment.
23andMe has a Chinese venture capitalist.
We have a
not?
we have a small fraction. We haven't taken any Chinese money recently at all, but we have a small investor in an old round of a few $100,000. So we don't have significant Chinese ownership.
Really good question. Name, title, and then very brief question. We're going to run out of time here.
Sean Ray, I'm a VP of Government Programs at Certes Networks. We're a crypto company. But so I was a member 20 years ago of the Consumer Privacy Exchange Consortium, where we were trying to say, hey, all these websites are coming up, all this stuff is going online, all your CRN data. And what turned out was basically the government and some other programs tried to fight off this and say, you have to do this. But in the news, it says, oh yeah, this privacy, you should be worried about it. But what I'm more interested in is how do you keep getting the services that you need if you say no? Right? We talk about you have the right to sign this document, or you have the right to do this, but in all reality, anybody who lives in California and is here today and gets on a website and says, hey, we use cookies, you want to do the next page, you do the
Great.
It's the same thing in the health field. I just finished going to 5 different of the leading cancer centers in America, and if you don't sign and say we can do whatever we want with your tissue samples or with your stuff,
Go back
we're
home.
not going to help you. Go home.
Yep. Awesome. Great question.
Yeah, so that concerns me a great deal as well, because I think both on the clinical side and that we do want research to continue, we need to figure out how to balance those two things. I would love to see better consumer pressure, though, on opening up the black box that is those medical centers and what they do with the data and the fact that they are selling it and they're not telling anyone. That sort of stuff to be clearer and not as black box would make it better in terms of, at least in terms of what I see. But you're absolutely right that I think most people, particularly if they're not well, will go go right past whatever it says and give their data to whomever. I have an example of taking my Facebook page for the disease my kids have, 4,000 people, and saying, we're going to shut it down tomorrow. Cambridge Analytica happened. This is really awful. Look at the Chinese government is doing blah, blah, blah. And to a person, all 4,000 consented again to say, we're staying here. It's the only way in this rare disease we see each other across the world. So I think it's up to those of us who are leading to figure out how do we change. And I appeal to the CEOs and the heads of the major medical centers to start to reveal more about what they're doing, what is their business, that Google and Ascension is happening, that patients like me has been invested in by the Chinese, that be revealed by the people that are the leaders themselves and not by some government agency coming in and clapping down on them.
So that is a fantastic close to the session. I'd like to very much thank everyone in the group here, as well as our 4 esteemed speakers, Dr. Patrick Cornea, Kathy Hibbs, Sharon Terry, and Mike Wilson. Thank you all for exploring this space.
Thank you.